This holds 465,000 gallons or 2 million liters of ice-cold liquid oxygen. It is chilled to minus 180 degrees C or nearly minus 300 degrees Fahrenheit. So a pretty special place to be standing with a great view of the rocket. Now, Solar Orbiter is a really interesting mission. Hi, I'm Tori Bruno. I'm at the historic Space Launch Complex 41, home of the amazing Atlas rocket and soon to be home of the Vulcan Centaur rocket as well. And this is a very special day because right now we have an Atlas on the pad carrying the Solar Orbiter probe that will return to the Sun for even more exciting science. I am standing at a very unique vantage point. I am on top of the main liquid oxygen storage tank. This holds 465,000 gallons or 2 million liters of ice-cold liquid oxygen. It is chilled to minus 180 degrees C or nearly minus 300 degrees Fahrenheit. So a pretty special place to be standing with a great view of the rocket. Now, Solar Orbiter is a really interesting mission. We're going to launch it here on this Atlas with a very precise trajectory, injecting it with an exact amount of energy, something we call C3, the characteristic energy, in this case 30.05, to send it on a perfect trajectory away from the Earth, escaping Earth's gravity well, and then doing gravity assists for several years with Venus and the Earth gradually pulling its closest point, its perihelion, inside Mercury's orbit to get a great view of the Sun while lifting its inclination so that it will actually see, really for the first time ever, a direct view of the solar poles. So really exciting science and a great complement to the Parker Solar Probe that we launched in 2018 on a ULA Delta IV Heavy rocket. Now, I get a lot of questions about the unique configuration of this Atlas. This is the one we call the slider, the 411. It has a single SRB, and the combination of that liquid core with that single SRB together give exactly the right amount of thrust. 5.3 million newtons or 1.2 million pounds of thrust to put Solar Orbiter on that exact trajectory. Now, the thing that I think always throws people is, gosh, the rocket looks so asymmetric. There's the center core with its liquid rocket engines, and then there's this big solid hanging off the side. How do you control and steer it? Well, two things. First, we have a fixed nozzle on that solid rocket motor that is canted at an angle so that its thrust vector passes through the average center of gravity of the rocket. So it has very little moment, much less than you would think if it were just, say, for example, pointing straight down. And then in addition to that, the RD-180 engines underneath the Atlas have a tremendous amount of thrust vectoring, what we call control authority, that can steer through any asymmetries that are left over as the center of gravity moves on that rocket. Even though the nozzle is fixed, it moves because the rocket is 90%, greater than 90% propellant. It is getting lighter and lighter when it flies, and the center of gravity is actually moving. So we can steer through all of that and provide this very precise trajectory. Well, I hope that was interesting to everybody. And now I've got to get back to work because I'm up here to do my job.